This video is going to cover Module 2. It's going to cover both homeworks 8 and 9 because both of them talk about the division of polynomials. So if we have 7x squared minus 9 divided by x minus 3. So up top we have 7x squared minus 9. On the top of our fraction is our dividend. On the bottom is our divisor. So on the bottom in this case our divisor would be x minus 3. So dividend is up top, divisor is on the bottom. So we can write division a couple different ways. We can actually use the division symbol and say dividend divided by divisor is our answer, or answer is the quotient. We could write it as a fraction because fractions mean divide, so dividend over divisor equals our quotient. Or we can use a long division symbol and say our dividend divided by our divisor is our quotient up top. So a little vocab for you. So our first example, negative 75r to the fourth plus 30r cubed minus 50r squared plus 9r plus 16 divided by negative 5r. So I'm going to rewrite this in our fraction form that we talked about earlier. So we're going to do negative 75r to the fourth plus 30r cubed minus 50r squared plus 9r plus 16 all over negative 5r. So notice we're dividing everything by one term. So because we're dividing everything by one term, I can rewrite each term as a little fraction all over negative 5r. So for example, negative 75r to the fourth divided by negative 5r plus 30r cubed divided by negative 5r minus 50r squared divided by negative 5r plus 9r divided by negative 5r plus 16 divided by negative 5r. So now we have simpler, easy, smaller fractions to deal with. So we can simplify each one separately. So here we have negative 75 divided by negative 5, which in our calculators, negative 75 divided by negative 5 will give us 15. We're dividing r to the fourth divided by r. So r to the fourth divided by r to the first. Remember, whenever we divide, we are going to subtract our exponents. So r to the fourth divided by r to the first, subtracting 4 minus 1 will give us r cubed. That's positive, so it's good. It could stay up top. Again, we have 30 divided by negative 5, which is negative 6. R cubed divided by r to the first, subtracting those exponents will give us r squared, r to the second power. Negative 50 divided by negative 5 will give us positive 10. R squared divided by r to the first will give us r to the first, or just 1r, so plus 10r. Next, we have positive 9 divided by negative 5. So because it's a positive divided by a negative, our answer is going to be a negative. 9 and 5 have nothing in common, so they're going to stay 9 over 5. I have 1r up top, 1r on the bottom, so they're going to cancel each other out. Another way to think about this is I have r to the 1 minus 1, which is r to the 0, which is 1. So that's why those r's cancel each other out. And last but not least, plus 16 divided by negative 5r. Again, a positive divided by a negative will give us a negative. There's nothing that 16 and 5 have in common, so we're going to leave it as 16 and 5. There's only 1r on the bottom. There's nothing to simplify with that, so it's going to stay 1r on the bottom. So there's no like term, so our final answer will be 15r cubed minus 6r squared plus 10r minus 9 over 5 minus 16 divided by 5r. Same thing for our next example. We have 5x squared plus 1 divided by xy. We're dividing by one term, so I can break this up and write each term separately as its own little fraction over xy. So we have 5x squared over xy plus 1 over xy. Simplifying each one separately, that 5 is going to stay up top. I have two x's on the top, one on the bottom. So dividing, we can subtract our exponents, so 2 minus 1. That 1y is on the bottom, so it's going to stay on the bottom, plus 1 over xy. There's nothing to combine with those xy, so they're just going to stay on the bottom. So we're left with 5x. 2 minus 1 will give us x to the first power, or just x, all over y, plus 1 over xy. We're going to leave these as separate fractions. That'll be our final answer. So 5x divided by y plus 1 over xy. Next example, we have 4m to the 7th minus 16m to the 6th plus 28m squared minus 4m to the 5th. Again, we're dividing by one term, so I can split up each term and write them separately as little fractions all over negative 4m to the 5th. So 4m to the 7th divided by negative 4m to the 5th minus 16m to the 6th divided by negative 4m to the 5th plus 28m squared divided by negative 4m to the 5th. So simplifying each one separately. Positive 4 divided by negative 4 will give us negative 1. M to the 7th divided by m to the 5th, we're going to subtract those exponents. So that'll leave us with negative m. 7 minus 5 is m squared. So negative m squared. Negative 16m to the 6th divided by negative 4m to the 5th. Negative 16 divided by negative 4 will leave us with positive 4. And then subtracting our exponents. So positive 4. M to the 6 minus 5 will leave us with m to the first power, or just m. Next, we're left with 28m squared divided by negative 4m to the 5th. 28 divided by negative 4 is negative 7. And then subtracting our exponents, we have m to the 2 minus 5. So negative 7, m to the negative 3 power. Because that power is negative, that has to flip down to the bottom of our fraction to become positive. So we're left with negative m squared plus 4m minus 7 over m cubed. This is its own little fraction, this negative 7m cubed. So make sure you leave it separate from the other ones. So the m cubed is only over the negative 7. So negative m squared plus 4m minus 7 over m cubed is our final answer. Next example, we have 5x squared plus 1 all over x plus 2. This one's different because in this example, our divisor is more than one term. So we have x plus 2, so it's two terms. So that means we can't split it up like we did up here separately. So we have to use either long division or synthetic division. In this class, we're just going to use synthetic division. So synthetic division is just a shortcut, an easier version than long division. So it's the same concept. But for synthetic division, we just deal with the coefficients. We just deal with the numbers, and then we come back and put the variables back in at the end. So with that being said, I need a divisor to start off with. So I'm going to take my divisor x plus 2, and I'm going to set it equal to 0. Solving, I'm going to subtract 2 from both sides, and I'm left with x equals negative 2. So this is going to be my divisor. This is going to be the number that goes into my little box. That's going to be my divisor. So now each column is going to represent a different variable, because we said we're going to leave the variables off till the very end. So starting off, we have x squared, so that's what we're dealing with. That's our leading term. Then we have x to the first power, x to the 0 power. So notice they're in descending order. So x squared, x to the first, x to the 0. It's in descending order. So over here, I want to make sure I have all of my variables like I did here written in descending order. So I have 5x squared. I don't have any terms with just x, so plus 0x plus 1. So you can't forget to write your placeholders. So there's no term with just x in it, so we wrote plus 0x. So now I have 5x squared, so 5 is going to go in my x squared column. 0x, so 0 is going to go in my x column, x is the first power. And then 1, that is a constant without a variable, so 1 is going to go in my x to the 0 column. So now we have this set up, so now it's just going to be a pattern that we're going to roll through. For our pattern, we have to start somewhere, so I want to bring down this first number. I want to bring down that 5. So now our pattern starts. So we're going to multiply up and then add down. So multiplying up, 5 times -2 is -10. And then adding down, so 0 plus -10 is -10. Again, multiply up, add down. So multiplying up, -10 times -2 is +20. Adding down, 1 plus 20 is 21. So we're going to multiply up, then add down. So we're left with 5, -10, and 21. Putting our numbers back in. Our variables back in. So remember, we started off with a x squared term, and then we're dividing by an x, or taking away an x. So we're just left with x to the first power. So 5x to the first power minus 10, that'll be x to the 0 power, plus our remainder, which is written over our divisor of x plus 2. So our final answer here, and I'm sorry I'm running out of room because it was supposed to be on the other page, will be 5x minus 10 plus 21. Let me write it on the other page. Here's this, just rewriting the answer on the next page. So 5x minus 10 plus 21 over our divisor, which was x plus 2. So if you notice, So if you notice, this was x to the first power, this would be x to the 0 power, and then the last thing is whatever's left over. Whatever's left over is our remainder. Our remainder is always written over our divisor. So we took out and we wrote it in order. We took out the variables at the beginning. Now we're just putting them back in order. So we divided by x squared, and we took away, we divided by an x. So we're left with just one x. Then we have 0x, and then our remainder going in descending order. Let's try another one. So we have -6 plus 5x cubed plus 4. Again, let's rewrite this with our placeholders in descending order. So 5x cubed. I do not have any x squared terms, so plus 0x squared minus 6x plus 4. All over our divisor, which is x minus 2. Again, I'm going to set that x minus 2 equal to 0. I'm going to add 2 to both sides to solve for x. We are left with x equals +2. So that's going to be the number that goes into my little box as my divisor. So we're starting off with x cubed. So I have x cubed, in descending order x squared, x to the first, and then x to the 0 power, which is my constant with no x's. So I have 5x cubed, 0x squared, -6x, and then +4. So we have it set up. Remember, we're going to multiply up, add down. Before we do that, I need to start somewhere. So I want to bring down this first number, bringing down the 5. So we're going to bring down. So let's start off, let's write our, so we need to write polynomial in descending order. So going down with any placeholders. And then we need to find our divisor. So we're going to set denominator, set the bottom of our fraction, equal to 0, and solve. Then we're going to bring down the first number. And then we're going to multiply up. And then we're going to add down. Then lastly, we're going to put the variables back in. Oops. All right, so we brought down the first number. Multiplying up, 5 times 2 will give us 10. Adding down, 0 plus 10 will give us 10. Again, multiplying up, 10 times 2 will give us 20. Adding down, negative 6 plus 20 will give us 14. Multiplying up, 14 times 2 will give us 28. Adding down, 4 plus 28 will give us 32. All right, so our last thing is putting our variables back in. We had x cubed. We divided by x to the first power. We took away an x. We subtracted an x. So we're left with x squared. So we have 5x squared in descending order plus 10x to the first power plus 14x to the 0 power, so no x's. And last but not least is our remainder, which is 32, over our divisor, which is x minus 2. So that's our final answer, 5x squared plus 10x plus 14 plus 32 all over x minus 2. This is Module 2, homeworks 8 and 9.